Hello, this is Antero Oliva, and this is climate lesson number 4, Absorption of Radiation. I would like to introduce what happens in the absorption and in which way the temperature is elevated because of absorption. Everything starts from photons. Photons are real workhorses of the universe. They are called elementary particles. It means that the mass of these particles is very small, utmostly small, much smaller than the mass of atom. And a photon has properties of particles. It has a mass in certain circumstances, and it behaves also like waves. It has certain wavelength or frequency. And in the case of the Sun and the Earth, the wavelength range is from 0.2 micrometers to 100 micrometers. But it can be much smaller or much longer, like in the case of radio waves. So a photon is a special particle. It travels with the speed of light, and when it's traveling with this speed, it has a mass. There is an evidence that there is a mass. When the light beam from a faraway star is traveling or bypassing the Sun, this beam is deviated a little bit, and the reason is the gravitational force of the Sun. And that means that the photon has a mass. And it can travel through the emptiness, for example, from the Sun to the Earth. And that's why there must be a mass. But when it's absorbed, this mass disappears totally, not partially, but totally. That's a special feature of the photon. And this mass is so small that the scientists are not able or not willing to calculate what is the size of this mass. At least I have not seen any determination of the mass of a photon. So here I have a simplified presentation of the atmosphere below 2 kilometers. And that's why there is a certain amount of water molecules. Water molecules are here. There is oxygen and 2 hydrogen atoms. It's making water molecules. And then I have 1 carbon dioxide molecule. It means there is carbon atom and 2 oxygen atoms. And the relationship of these molecules between water and carbon dioxide is 30:1, because that is the concentration difference below 2 kilometers. And I have here 1 oxygen molecule. I have here only 1 oxygen molecule, but in fact it should be full of nitrogen and oxygen molecules. But then we would not see anything else but those molecules which are inactive when we talk about absorption. And what happens when a photon collides with molecules? It depends. If it's inactive molecule like a nitrogen or oxygen, the collision is elastic. It means a photon is bounding into any direction and it doesn't lose its speed. And when it hits a greenhouse molecule, it depends what is the frequency of a photon and the absorption frequencies or wavelength of a greenhouse gas. If they match, a photon will be absorbed. But if there is no match, then there is no absorption. It's only elastic collision. So I have here a simple presentation what happens when a photon hits a water molecule with a certain frequency. And let's think that the water molecule has a proper absorption frequency, so it is absorbed. And the next thing what's happened is that the photon loses its mass. There are internal vibrations inside of a water molecule, and it can hit any molecules like nitrogen or oxygen molecules. And that way, the energy released by the photon is transformed into temperature. Temperature simply means that there are more internal vibrations inside of a molecule, or there are external collisions between the molecules. And when it's hitting a molecule, it is maybe hitting other molecules. And that's the way the temperature is getting higher in a gas mixture. And that's not all. Thereafter, a water molecule will emit a new photon, having a different frequency, less energy. And that's what we can say, that this absorption procedure, it's like emitting, absorption and emission of photons. And the result concerning temperature is that the temperature is getting higher because some part of energy is released as a heat. The absorption of infrared radiation depends on two things. It depends on concentration and it depends on vibration modes of a greenhouse gas. You may have an idea that bonds inside a molecule are very solid, but that's a wrong idea. These bonds are actually very flexible, and we could think that they are connected with a spring. Then we have a right idea about the nature of these bonds. Here we have a carbon dioxide molecule, and it has 4 vibration modes, and 3 of them produce heat. In the case of water molecule, there are 6 vibration modes, and this is because a water molecule has a special mechanical or physical structure. Hydrogen atoms are connected in a way, a symmetrical way, to the oxygen atom. And that's why water molecule has a wide range of different absorption wavelengths or frequencies. And the end result of this is that the absorption depends on concentration. Greenhouse gases has no fancy magnetic forces that they could attract photons. It's simply based on concentrations. It's directly proportional to concentrations in which and how much photons are hitting greenhouse gases. But then there are these absorption characteristics of greenhouse gases, and it can change this situation a lot. The absorption characteristic means that the absorption producing heat can be very low or very strong. And what is the case is nowadays very well known. The molecular physics knows these features exactly.